All right, so in the last unit, we were factoring quadratics. In this next unit, we are going to be graphing and solving them. And so starting with graphs and key attributes, most of this is just vocabulary. And so quadratic functions refer to equations in the form f of x equals ax squared plus bx plus c. This square is what makes it a quadratic, whereas linear would just be like ax plus b, or we used slope-intercept form. Those graphed a line. Quadratics graph what we call parabolas, and it makes a U shape. Okay, and so the linear parent function was y equals x. The quadratic parent function is y equals x squared. Or we could use function notation, f of x equals x squared. That's this graph right here. Okay, and so some key attributes that we're going to bring back from Unit 1 is the domain, which is your x values. Those are the sides of your box if you were to box your function. And because this function is going to break through both sides of our box, it goes on to negative infinity and positive infinity, which we just say all real numbers. Okay, so a quadratic function will always have a domain of all real numbers. You never have to think about it. So it's kind of like a free answer for the test. All real numbers for your domain all the time. Your range is harder. Okay, the range is the bottom and top of the box. And so for the parent function, it has a bottom of the box at y equals 0, but there is no top. These arrows would bust right through it. And so because the function is above the 0 line, we're going to say y is greater than or equal to 0. And so anytime you have a parabola opening up, it's going to be y is greater than or equal to this bottom number. Whereas if it's opening down, it's going to be y is less than or equal to. And so you can kind of remember that below goes with your less than sign. Okay, and so range is always your y, domain is always your x, and it's always all real numbers. Some other vocabulary we need is the vertex of the parabola, which is the highest or lowest point. It's really important that you know that the vertex is a point, and it's this point right here. And so in the case of our parent function, it's on the origin, so just 0, 0. The other vocabulary we need is the axis of symmetry, sometimes called the line of symmetry, abbreviated AOS. It is the vertical line. And so that's important, that it's always going to be an x equals equation. Always the x equals. If you don't have the x equals, it's wrong. And so for our parent function, this axis of symmetry is the line, the vertical line x equals 0. It crosses the x-axis at x equals 0. Next we have, let's use purple, the minimum / maximum, which is either the lowest or highest point. So in the case of a parabola, like our parent function, we have a minimum. If the parabola is upside down, we have a maximum. And so our minimum is right here at the vertex. Sometimes your vertex is the maximum, sometimes it's the minimum. All right, the solutions is where the parabola crosses the x-axis. We also call them x-intercepts. We actually have 4 different names. We'll talk about that later. X-intercepts. Okay, and so let's look at our first example. So the vertex of this graph is right here. X is 1, y is 3. So the point 1, negative 3 is the vertex. The axis of symmetry is this vertical line right through it. I didn't mean to have that arrow. And so x equals 1. You have to have that x equals or it's wrong. And so since the vertical line always goes through the vertex, this number and this number should always match. Okay, and then because this is the bottom of the box, this is our minimum. There's no top of the box, so there's no maximum. And then the x-intercepts are at negative 1 and 3. And so remember, x-intercepts are x values when y is 0. Whereas the y-intercept, which that will be on your exit ticket, so let's go ahead and fill that in. The y-intercept is a y value when x is 0. So in this case, 0, negative 3. So the most important thing you need to remember is that the vertex is a point, whereas the axis of symmetry is an equation. And your x-intercepts and y-intercepts are points. Okay, your range is an inequality. And then domain is all real numbers all the time. All right, and so part of our function, most of the functions are going to be given in the equation form, not the graph. And so if you're given the equation, and if you look at the a value, if a is negative, you can already tell a lot of information about it. And so a is less than 0 means negative. And negative means it's opening down. And so I think of it as a sad parabola. It's frowning. Okay? And so anytime you see that a is negative, so let's get an example. Like y equals negative 3x squared plus 2x plus 1. Because this a value is negative, we know it's going to be a sad parabola, which also tells us that the vertex is going to be a maximum. Whereas if our a value is positive, a is greater than 0, that's positive. So it's happy. It's smiling. So it's a happy parabola. So an example would be like y equals 3x squared plus 2x plus 1. We already know this function is going to have a minimum. Seems kind of backwards that positive goes with minimum, but if you draw the picture, it makes more sense. So maximum for a negative sad parabola, minimum for a happy positive parabola. Okay, and so when you're given the equation form, we're going to just graph it in Desmos to get all of our key attributes, but this would save you some time if you just need to know if it's a max or min. Later, when we're solving these, we really need to make sure we can identify A, B, and C values. And so this next part is just a review of that. So in the case of number 1, there's an invisible 1 for our A value. And then B is 5 and C is -6. So 1, 5, -6. In the case of number 2, there's also an invisible 1 here, but this time it's -1. And then we have a -2, don't lose your negatives, and then a +1. So -1, -2, +1. In the case of number 3, notice we go straight from our x squared term to our constant term. That means we're missing our x term. So if I were to rewrite this with the x term, that means the coefficient was 0. Okay, and so now I can see my A value, my B value, and my C value. 4, 0, -9. And then number 4 also only has 2 terms, but this time we have our x squared term, then our x term, and we're missing our constant term. And so our +0 is at the end as our C value. So -2, 5, 0. And so looking at 1 and 3, both of those have positive A values. And so we know we have a happy parabola, whereas 2 and 4 are negative, so we know that's a sad parabola. In this case, we have a min. Here we have a max. Here we know we have a min. Here we know we have a max. All right. And so when we get to solving, quadratic functions can have up to 2 solutions. And then remember, solutions are the x-intercepts. And so this is where I want you to write the acronym ROXS, R-O-X-S. These are going to be the 4 different names we have for x-intercepts. And so one of them is called roots. The other is zeros. We call them x-intercepts. And we call them solutions. Same thing. They're the x value when y is 0. And so with parabolas, we can have up to 2 x-intercepts because it makes a U shape. And so, for example, if my graph, I'm just picking random points, looks like this, it has 2 solutions or 2 x-intercepts. In some cases, we may have a graph with the vertex that is the x-intercept. That would be 1 solution. And sometimes we have weird cases where it doesn't cross the x-axis at all. Sorry, that's not very symmetrical. I'm going to do better. And in that case, no x-intercept means no solution. Okay, so those are our 3 different cases. You could have 2 x-intercepts, you could have 1 x-intercept, or you could have no x-intercept for parabolas. So let's do some examples. Okay, so starting with this first example, A is 1, B is -4, and C is -5. And so to get our key attributes, let's go to Desmos and just graph them. And you can do this on the exit ticket too. I'm going to split. Okay, so when you're typing this equation in, you can type f of x, f parenthesis x equals, or you can do y equals. You just don't want to type x equals. That's where a lot of people mess up. So f of x equals x squared minus 4x, minus 5. Okay, it already plots some of the points, so we just got to click on them. So I have an x-intercept at -1, an x-intercept at 5, a vertex at 2, -9, a y-intercept at 0, -5. And so for the vertex, we're going to put 2, -9. And then the axis of symmetry would be that vertical line right through the vertex. And so remember, this number and this number should always match. Okay, because it's a happy parabola, we have a minimum, not a maximum. Domain is all real numbers all the time. And then the range, because this vertex was our minimum, we're going to have y is greater than or equal to the y value of the vertex. So this number and this number should always match. And then our x-intercepts, -1, 0, and +5, 0. They didn't ask for the y-intercept, but it's on your exit ticket, so let's go ahead and put the y-intercept as well. 0, -5. Okay. For the second example, A is -1, B is 10, C is -21. And so because the A value is negative, I already know I'm dealing with a sad parabola. And so I can come down and determine right off the bat that I'm going to have a maximum. And then I know my range is going to be less than or equal to whatever that maximum value is. I know domain is all real numbers all the time. And now let's use Desmos to get a good picture. So f of x equals negative x squared plus 10x minus 21. We got x-intercepts at 3, 0, and 7, 0. And then we have a vertex at 5, 4, which means our axis of symmetry is x equals 5. Don't forget the x equals or it's automatically wrong. And then the range is going to be less than or equal to that 4. So we're going to put that right here. Oop. Undo. 4. And then let's add the y-intercept, which is 0, -21. Right, that's it.